Okay, so I happened to do the entire thing and not record it. So I'm just going to be pushing the forward, the redo thing, and just explain as I go. So what we're going to be doing here is doing an array. We're going to use a for loop and a few if statements to collect or distinguish the greatest and the least valued arrays. The elements within the array. We're going to say where it's coming from, which element is coming from, and the value that is within that element. So we're going to start. We're going to need an integer x, the counter integer, integer sm, which will be the element that's going to be the smallest. Another integer for the greatest, that's element counter, int g, which is going to be for the greatest element's value, and s, which is going to be for the smallest element value. We have okay, we're going to say it's a 6. It's got 6 in the element. Okay, 5. Okay, that's what I said, 5. Okay, we're going to set that equal to, looks like 10, 89, 5, 7, and 4. Now we need 4, x equals 0, x less than 5, x plus plus. We're going to close that, start the bracket. If the element, if sm is, I'll also set those equal to 0 up at the top over here, if you can see those, just so it'll be the same. So I said if sm is greater than a, if the smallest one, which is the first one at this point, is greater than the element which we are currently on, then the smallest one is equal to x.
You didn't record for real.
Yes, I didn't record for real. Shut up. It's not funny.
Yeah, I said it too.
Yeah.
That was even the funnier part about it.
Yo, just shut up, okay? Alright, then we set
I
S.
think you check, as soon as I said just to
Yeah, you jinxed it. That's all that happened. Okay.
You gonna do it again?
No, shut up. S is, okay, what did we say? Okay, we got SM over here, which is the X. And then S, which is the element's value. The smallest one will be AX now. It will replace it to AX. And we're going to close that. Now we're doing it for the greatest if the element at greatest is less than the element at X, or the array at X, then what did I have there? Why is that still there? Why is this still here? Okay, then GT equals X, and G equals the element at X. Then we have C out smallest at SM is equal to that number, which is equal, which the value is S. Now we continue on, and then we're gonna, I copied and pasted just to make fast, which means the greatest at this particular value will be G. And let's go ahead and run that since there are no more forwards. Oh, okay. Let's go ahead and run that. This isn't supposed to be here. That could probably screw something up. Okay. Now we're going to compile this and run it. So the smallest is happens at the first, really? Which is 4. No, something happened. Smallest is at 0. Why did it go to 0? It got the value right, which is funny. Oh, I see what happened right here. I must have deleted it or something. That was the thing. That's where it came from. Okay, let me go ahead and... Okay. SM equals X. Okay, now it's fixed. Okay, now you see. Whoa, move the wrong thing. Okay, the smallest happens in the 5th array, which is 4 if you go from 0 to 4. Okay, it happens at 4 and its value is 4. The greatest happens at 1, which is 2, and that value is 89. And that concludes it. There we go. Stop.